Okay, ladies and gentlemen, this is the very last lesson for MPM 2D grade 10 academic math. I can't believe I'm saying it. We've made it. And the nice thing about this lesson is it is nothing new. We are just going to use all of those skills in our trigonometric arsenal to solve a variety of word problems, okay? The front of the note is a bit overwhelming. It's a giant chart and table. I've kind of summarized it in this little graphic organizer. It's nothing special, but I just find that it really does sort of present everything we've learned in a concise way. So when we talk about solving triangles, it's a little error there, we have two categories, right? We have 90-degree triangles, and then we have I should add something to this. And we have non-90-degree triangles, either called an oblique triangle, okay? Or in this case, we're mostly looking at acute triangles. I should add this here. We have good old Pythagorean theorem. I forgot about him. Pythagorean theorem. Okay, so if the triangle contains a 90-degree angle, prior to grade 10 academic math, the only thing you knew how to do was employ the Pythagorean theorem to find a missing side given two other side lengths. Now, we have all these neat tools up our sleeve because we no longer need side lengths. We could be given a side length and an angle, and we can go on to solve the triangle using the primary trigonometric ratios, SOHCAHTOA. Okay, so these guys can only be used in 90-degree angles, okay? That's why we had to introduce this whole right side of the graphic organizer, because not every triangle contains a 90-degree angle. And so we have the sine law and the cosine law. Just a reminder, the sine law can only be used when you have a set of opposites. And what I mean by that is a side and the opposite angle, okay? And when we did the sine law, I called that guy my superstar. That's the only piece of the sine law, or that's the fraction where you know the top and you know the bottom. So you must have a set of opposites plus another side or angle. In order to use the cosine law, you must have three sides or two sides and the contained, or the middle angle. Not any angle, the contained angle. Now, right here, I have a little bubble stating that all angles, interior angles of a triangle add to 180. And we use that trick quite often, right? If we're trying to solve a triangle and we already have two of the angles, we can super quickly find that remainder, or that remaining angle, simply by subtracting from 180. So the front page of that note, like I said, there's a pretty long detailed chart on it. Have a look, but I'd rather kind of just navigate this lesson strictly by going through the examples together. The hardest part of this lesson is drawing the diagram correctly and then making sure you're actually solving for what is being asked. So that's what we're going to do together. We're going to do a series of examples to see if you can distinguish when to use each of the tools, and then we are officially done grade 10 math. Okay, so question number 1. Two people looked up at the sky and saw Superman flying. Person A was to the left of Superman. So let's get the diagram going. S, Superman. Person A was to the left of Superman. Person B was to the right of Superman. Okay, and let's turn this into a triangle. Beautiful. The angle of elevation, and we talked about those terms, and they're going to come back to haunt us in this lesson. So an angle of elevation comes up from a horizontal. So we know we're either coming from here or here. The angle of elevation of person A to Superman was 65 degrees. And person B to Superman was 80 degrees. Remember, an angle of elevation must come from a horizontal. It couldn't possibly be there. The two people are standing 30 feet apart from one another. Compute the distance from person A to Superman. Okay? So the first thing I'm going to do is label this using small case letters. If this is big angle S, this is little side S. Big angle A, little side A. Big angle B, little side B. Okay? I know for a fact I am not going to be using the primary trigonometric ratios or the Pythagorean theorem because this triangle does not contain a 90-degree angle. Okay? And if I wasn't 100% sure of that, I could just take 180 and subtract the angles that I was given, 65 and 80, and this guy is 35 degrees. So for sure, there is no 90-degree angle. So that means I'm either going to use the sine law or the cosine law. I know I'm not using the cosine law as it applies to three sides because I only have one side. And I know I'm not using the cosine law because I would need two sides and a contained angle. I only have the one side. So this must be a sine law question. How do I know it's a sine law question? Because I have a set of opposites, I have big S and little s, and I only need one other piece of information. In this case, I was lucky enough to be given two. So I have a set of opposites and one other piece of information, again, in this case, two. This is a sine law question. I'm being asked to solve for little b, okay? So I am going to say that the sine law, or the sine, pardon me, of big S over little s is equal to the sine of big B over little b. I could go on to say equals the sine of big A over little a, but I don't need little a. This is what I was asked to solve for in the question. Now that I have that written down, let's go ahead and fill it in. The sine of big S, which is 35 degrees, over little s, which is 30, is equal to the sine of big B, which is 80 degrees, over little b, which is my unknown, okay? Now I'm going to go ahead and cross multiply. If I'm trying to find little b, I'll multiply with that first. So that tells me that little b times the sine of 35 degrees is equal to 30 times the sine of 80 degrees. And if you had said the sine of 80 times 30, that's fine. You get the same answer. We want to isolate little b or get it by itself, but it's being multiplied by the sine of 35 degrees. So I'm going to divide both sides of the equation by the sine of 35 degrees. When I do that, these guys cancel, which is exactly what I wanted. And now I can notice I haven't touched my calculator yet. Now that I'm ready to go right to the final answer, I'm in degree mode and I can do that in one step. So 30 times the sine of 80 equals divided by the sine of 35. Do I have to sine inverse this? Absolutely not, because I'm not solving for an angle, okay? So little b is equal to 51.51. In this case, the question was given to me in feet. So I will put feet. On an assessment, folks, please don't waste your precious time writing a sentence. All you need to do is give me the final answer with a box around it and the units rounded to 2 decimal places. Okay, I absolutely love question number 2 just because it really is a beautiful real life application of trigonometry, especially because we have students in our own school that use wheelchairs and would need a ramp. And so this is great. It's a great way to see trigonometry at work. So a 20-meter wheelchair ramp forms an angle of 5 degrees with the ground. And I had someone message me on Edsby with a question about this, and I'm so glad they did. So it's a pretty safe assumption. Anytime we're talking about a question involving a ramp, unless otherwise stated, you can assume that it involves a 90-degree triangle. So right away, that's kind of like the light bulb going off. This is going to be either a Pythagorean theorem or a SOHCAHTOA type question. Now, the big question is, where do we put the 20? The wheelchair ramp is 20 meters. Folks, ramps don't go vertically up and down, and they certainly don't lie on the ground. If this was the ramp, I wouldn't be getting anywhere. The ramp is always on the diagonal. Okay? And it forms an angle of 5 degrees with the ground. So if that's the ramp and that's the ground, then that there is the 5 degrees. I know that degree sign looks a little wonky. My marker's too thick. Okay? It says to meet the province's new accessibility guidelines, the ramp must be changed to form an angle of 2.9 degrees. So what they're saying is, at the current time, that's too steep. Okay, it's not safe. They need to shrink that angle. Now, let's think about this for a second, okay? Let's say they left the ramp alone and shrunk the angle. Okay? We're not going to get where we need to be, right? There's going to be a drop off, and that's certainly not safe. They're not going to lower the door that the ramp is trying to reach. What they're going to end up doing is extending the ramp. So what we need to do, we need to find out, okay, how tall or the height of the ramp to begin with, right? We need to figure out, let's not call it h because that might get confusing with hypotenuse. We need to figure out how tall that ramp is. Then once we know how tall that ramp is going to be, okay, the height that it needs to reach, and we know that this angle needs to be 2.9 degrees, then we will have to solve for the new length of the ramp. So there's a whole lot of SOHCAHTOA going on here, okay? Let's start over here. Again, the existing ramp was 5 degrees and 20 meters, and we don't know how tall off the ground it reached. We have to solve for that, okay? At this point, folks, I'd like to think that you've done enough SOHCAHTOA practice. I'm not going to go through these super slowly, but if you have questions about it, please send me a message on Edsby and I will walk you through these examples, okay? So this is the angle. That makes this the opposite. This has got to be the hypotenuse. Which trig ratio has opposite and hypotenuse in it? The sine. So the sine of 5 degrees is equal to that unknown length over the hypotenuse, which is 20. When I cross multiply, okay, so I'm going to go degree mode, of course, the sine of 5 times 20. So that door is 1.74 meters off the ground, okay? So that's what I solved for first. Again, this is still going to be 1.74 meters. They're not moving the door. Let's say this is like an entry to the school. They're not rebuilding the school, okay? What they're going to do is rebuild the ramp so that it has a smaller angle, a smaller incline, but it can still reach that door or entrance, whatever you want to call it. That's 1.74 meters off the ground. So here, I need the hypotenuse, right? The new ramp. I have the opposite side. So again, this is kind of interesting. I'm going to use the sine, but this time it's the sine of 2.9 degrees. And I know what the opposite is, but I am now solving for the hypotenuse. And you have to be really careful because this is a very commonly made mistake. Kids just assume they multiply these guys together, but that is not the case. Y times the sine of 2.9 degrees is equal to 1.74. Now I need to isolate y, so I'm going to divide both sides by the sine of 2.9 degrees. These guys cancel, which is just what I wanted, and divided by the sine of 2.9, that ends up being 34.39. So the question said, how long will the new ramp be? The new ramp will be almost 35 meters, 34.39 meters. So again, try to take yourself out of just, what's the word I'm looking for? Like a robotic type, no thought question. Put yourself into the shoes of the people building this ramp. You have this ramp, it's 20 meters long, okay? It's too steep for the students that use it in the wheelchair. So we have to shrink the angle. If we're going to shrink the angle, the ramp's going to have to get longer to reach the same point on the building. How much longer? A good 14 meters, okay? 14.39 meters to be exact. All right. The second part of the question says, how much further along the ground will the new ramp extend? Okay, so let's say they wanted to build like a nice little sidewalk or something leading up to the ramp. Okay, so originally we don't know how much room it took up along that bottom there, so we're gonna have to solve for that. And I'm running out of letters. I've already used X and Y, but we're gonna have to solve for the amount of space that the ramp takes up on the ground. Then we're going to have to solve for the amount of space that the new ramp takes up along the ground and then subtract them to find the difference. Okay, so more SOHCAHTOA. The only difference is this time we're going to be using a different primary trigonometric ratio. Now I'm going to be honest. We know that this is 1.74 and this is 20. You could absolutely use the Pythagorean theorem here, but that's an old trick. I want to just, be able to practice using SOHCAHTOA, so that's what I'm going to do. Here, the cosine of 5 degrees is equal to, let's just call that little a, okay? Little a, so the adjacent side over the hypotenuse, which is 20. Again, cross multiply, make sure you're in degree mode. The cosine of 5 times 20 is 19. So originally, this ramp took up 19.292, meters along the ground. Now, yep, that's still on the shot. Now, the cosine of 2.9 degrees is equal to, we can call this b over the hypotenuse, which I solved to be 34.39, okay? Cross multiply again, so b times 1 is b. The cosine of 2.9 times 34.39 is 34.35, okay? And now that I'm actually looking at this, I easily could have used tangent here, right? Because I could have used that as my opposite and that as my adjacent. I could have used Pythagorean theorem. So at this point, you have so many different tools that you can use, which is kind of cool. Different tools mean different ways of checking your answer on an assessment. Okay, and so now if I want to know the difference, how much longer is it going to stretch along the ground? I'm just going to subtract those two values, and it is 14.43 meters longer along the ground. And that's what I get when I subtract those two values. Okay, so very cool question, especially if there's anyone in the class thinking of pursuing construction technology. I just think this is a great application that, you know, really truly applies to students within our own building. So very cool. Okay, example number 3. 2 airplanes depart from the airport at the same time. And I should specify here in different directions. Okay, so these guys are not flying side by side. Okay. On an assessment, I would be, you know, sure to make sure that I say that they are flying in different directions, okay? So one travels at a speed, so let's say this is the airport, okay? A for airport. One travels at a speed of 300 kilometers per hour. And then the other guy is traveling, and he's traveling at a speed of 375 kilometers per hour, okay? After 3 hours, the planes are 800 kilometers apart. Find the angle between their course. So this is the angle we want to find. And I bet a lot of you already know that this is a cosine law question because we are given 3 sides, no angles. We must use the cosine law. Before you dive in and start using the cosine law, we just have to do one thing. This diagram would be fine if the planes had only traveled for 1 hour, but they didn't. So we have to multiply their speed by 3 because this guy did not travel 300 kilometers. He did that for 3 hours. So he traveled 900 and this guy traveled 1,125 kilometers. Okay, and now that these are labeled, we're ready to go. Some students like to go ahead and label the triangle. I know, like with letters, I know in the teacher copy of the note I did ABC, but just to mix it up, let's do ACE, okay? Again, just so that you can sort of see, you know, different letters and practice writing out the cosine law. So if I am looking to solve for big angle A, then I need to write that out. The cosine of big angle A is equal to, and I hope by this point you can come up with the formula on your own, little c squared plus little e squared minus little a squared divided by 2ce. Okay? Once you have that written out, go ahead and fill it in. Actually, I haven't even labeled my diagram yet. I'm sorry. So big A, big C, little c, big E, little e. Okay? So little c, pardon me, is 1125 squared plus 900 squared minus 800 squared divided by, bracket, 2 times 1125 times 900. Okay, this is the cos of A. As I said before, you don't have to include this next step. You could go right to the final answer and I would be okay with that. If you do want to include this step, just because your calculator won't allow you to do it all in one step, that's absolutely fine, folks. Just minimize your chance of error here. Get me to the right answer. So we've got 1125 squared plus 900 squared minus 800 squared, which leaves me with this big monster on the top. In the denominator, I have 2 times 1125 times 900. I've got this monster on the bottom. Make sure you copy them correctly. Okay, so now I can go right from here to the final answer. Okay, so I'm going to take 1435625 divided by 2025000. That is not the final answer. Remember, we're finding an angle. I don't want the cos of A, I just want A. How do I get rid of cos? Cos inverse. And that angle is 44.85 degrees. Don't forget, This little guy's going to cost you a half mark if you forget him. So please make sure you include the units and a box around your final answer. You certainly don't have to write me a sentence, okay? Perhaps your grade 11 teacher will want you to write sentences, so don't say, well, Mrs. Kerr never made me. But I mean, in a spirit of saving time while you're writing an assessment, I don't need to see a sentence. Just put a box around the final answer. All right, ladies and gentlemen, this is the absolute last example of MPM 2D. A window in a building is 18 meters above the ground. Okay, so unless otherwise stated, you can assume that buildings grow at a 90 degree, or buildings stand at a 90 degree angle, okay? So window, this distance is, I labeled that kind of goofily, 18 meters. Again, the most difficult part of these questions is just making sure you produce the diagram correctly. So that's what you want to practice with the homework. And I expect to get lots of questions on EDSB about students wanting to know if they've drawn the diagram correctly. This is bothering me. I feel like it looks goofy. Okay, so window, building, 18 meters off the ground. Beautiful. From the window, the angle of elevation to the top of the building across the street is 40, okay? So there's a building across the street, and it's got to be taller because we have to be able to form an angle of elevation. Remember, an angle of elevation must come from a horizontal line. If there isn't one there, just add it in, okay? So here's the horizontal. The angle of elevation to the building across the street is 40 degrees, okay? Again, an angle of elevation must come from a horizontal. The angle of depression to the bottom of the building across the street is 42. So, window, angle of depression, right, must come. So often kids will put that angle here. No. It's got to come from the horizontal. So this here is 42 degrees, okay? How tall is the building across the street? Okay, so we are reverting back to SOHCAHTOA in this question, okay? This is a two-part question. The first thing that we're going to do is we're going to use the bottom half of this diagram to figure out this right here, okay? Because we know that up to this point right there, so let's actually fix this. We know that from here to here, that's 18 based on my diagram. What I don't know is that distance from there to there, okay? If I were to remove the bottom half of this diagram and I only had this top right triangle with the 40 degrees, that's not enough for me to figure out that missing side, okay? So I'm going to solve for the width or the distance between the two buildings and then use that to figure out this small chunk here, okay? This is what I'm solving for, so I'm gonna give this, I don't know, we can call it Y if we wanted to. Now, let's go ahead and finish labeling this triangle. You learned something in grade 9. I'm going to be honest, I don't remember the exact name of it because I haven't been in grade 9 since 1995 and I've never taught grade 9. But something about if you have a set of parallel lines as you do here, okay, that there's a Z pattern that goes like this. And that means that these angles are equal. So I hope that there's a big like, oh yeah, going on at home. And now I'm gonna go ahead and sort of take that bottom diagram and reproduce it so that it's just less confusing here. So I know that this angle is 42 and this is 18. So I'm just removing this diagram or this triangle from the diagram just to sort of simplify what's going on here. So I need to solve for this, right? This is that's my angle, which makes this my opposite. And this is the adjacent. And which trigonometric ratio has opposite and adjacent in it? The tangent. So the tangent of 42 is equal to 18 over little y. Careful, right? Whenever your unknown is on the bottom, you are going to cross multiply. And then you're going to have to divide to isolate y. So I'm not spending too much time explaining the calculations here because we've now been doing SOHCAHTOA a while. But as always, if you have questions, please message me on EDSB. 18 divided by the tangent of 42 is 19.99, what are these, meters? Meters. Which means that the distance from here to here is 19.99 meters. Okay, now, if the distance from here to here is 19.9, then the distance from here to here has to be 19.9 also. So now if we look at the top half of that picture, this is 19.99. This is 40 degrees. I need to figure out this, which I'm going to call x. Okay? Again, using SOHCAHTOA. So the tangent of 40 degrees is equal to x over 19.99, which means x, 19.99 times the tangent of 40 is 16.77. Okay, so in about 2 minutes, I'm going to go yell at my children. Hopefully I remember to shut the camera off before that. That chunk there is 16.77. This first half, or that first chunk, was 18. If we add those guys together, we get the height of the building, which is 77 meters. Okay? The only way to get comfortable with these types of questions is to do a ton of practice. So you need to navigate the homework. Please message me. Even sometimes all I have to do is take a picture of the diagram on my whiteboard and send it to you. And it'll definitely alleviate a lot of issues you might have with the homework. So I look forward to hearing from you. This is the very last lesson. It has been a slice.